students, welcome to this lecture 1 Triangles. So in this lecture we will discuss similar figures. Before starting similar figures, here I first introduce these chapters. Okay, then we'll discuss exercise 6.1. So let's get started. So you are familiar with triangles and many of their properties from your earlier classes. Okay, so in your earlier class, basically you have studied about triangles in your class 9th. Okay, and there you have familiar with triangles and many of their properties. So here recall that two figures are said to be congruent if they have the same shape and the same size. Okay, when two figures have the same shape and same size, then that two figures are said to be congruent. And in this chapter, we shall study about those figures which have the same shape, but not necessarily the same size. Okay. So in this chapter, basically we'll learn about those figures which have the same shape, but not necessarily the same size. Okay. So two figures having the same shape and not necessarily the same size are called similar figures. Okay, students. So what are similar figures? Similar figures are basically when two figures having the same shape but not necessarily the same size. Then that two figures are called similar figures. So here we introduced two terms. First is congruent and second is similar. Okay, so congruent means two figures are said to be congruent if they have the same shape and same size. Okay, when they have same shape and same size, then that figures are said to be congruent. But if two figures having same shape but not necessarily have same size, then that figures are called similar figures. Okay, so keep on in your mind these two terms, similar figures and congruent figures. Okay, so in particular we shall we shall discuss the similarity of triangles and apply this knowledge in giving a simple proof of Pythagoras theorem learned earlier. Okay, so we know about Pythagoras theorem, so we use this concept similarity of triangles. Basically we'll apply this knowledge in giving a simple proof of Pythagoras theorem that we learned earlier. Okay, so in class 9th you have seen that wall circles with the same radii are congruent. Okay, wall circle with the same radii. This is plural term of the word radius. Okay, radii. This is plural term of radius. So here we have seen in class 9, wall circle with the same radii are congruent and wall squares with the same side lengths are congruent. And equilateral triangles with the same side lengths are also congruent. Since all circles with the same radii actually having same shape and same size. Okay, that is why they are congruent. And all circles, all squares with the same side, they have same shape and same size. Okay, so they are also congruent. Equilateral triangles, all equilateral with the same side length, actually they have same size and same shape. That is why they are congruent. Okay, so now we consider any two or more circles. Okay, and here you can see this is given by this figure. So these figures of all circles, here we consider three one circle, and two concentric circle, and this is normal circle, and this is normal circle. So these figures, these figures of circles, here we ask you, are they congruent? Okay, so what is your answer? Are they congruent? Since all of them do not have the same radius and they are not congruent to each other. Okay, since the size of the circles not equal, not same. Okay, that means they do not have the same radius. That is why the figures that is shown in previous slide, they are not congruent to each other. And here note that some are congruent and some are not, but all of them have the same shape. But there is problem when the size is different. Okay, so all of them have the same shape, but the all of them do not have the same size. Okay, so that is why they are not congruent, and so they all are what we call similar. So when any two figures having same shape but do not have same size, then that two figures are called two similar figures. Okay, so two similar figures have the same shape but not necessarily the same size, and therefore all circles are similar. So all circles are similar since the shape of a circle are same for all. Okay, but the size of the circle do not have the same. So all circles are similar, all triangles are also similar, all squares also similar. Okay, they're all similars. What about two or more square or two or more equilateral triangles that is seen in figure 6.1, 2 and 3? Okay, so here it is shown the two or more squares of two or more squares. Okay, and here in these figures we have given two or more equilateral triangles. Okay, and we have asked what can you say about two or more squares or two or more equilateral triangle. Okay, so as observed in the case of circles, here also all squares are similar and all equilateral triangles are similar. Okay, so all squares are similar, all equilateral triangles are also similar. Now, from the above, we can say that all congruent figures are similar, but the similar figures do not be congruent. Okay, so congruent figures implies similar figures, but similar figures does not imply congruent figures. Okay, so for being two figures congruent figures, if they have same shape and same size. Okay, and two figures are called similar figures if they have same shape but do not necessarily have same size. Okay, so congruent figures, all congruent figures are similar, but similar figures need not be congruent. Okay, so can a circle and a square be similar? Now this is our question. Can a circle and a square be similar? And second question, can a triangle and a square be similar? So if you have a circle and if you have a square, okay, actually they do not have the same shape. They are different shape. Okay, so a circle and a square cannot be similar. And if you have a triangle and if you have a circle, okay, so the shape of triangle and shape of square, they are different. So a triangle and a square cannot be similar. Okay, so what can you say about the two equilaterals, two quadrilaterals ABCD and PQRS. So here we have given two quadrilaterals. One is ABCD and other is PQRS. Okay. So now question, are they similar? These figures appear to be similar, but we cannot be certain about it. Okay. So these figures appear to be similar, but we cannot certain about it. Therefore, we must have some definition of similarity of figures, and based on this definition, some rules to decide whether the two given figures are similar or not. Okay, so now we must have some definition of similarity of figures. Okay, and based on this, we can based on this definition, some rules to decide whether two figures that we have given to us are similar or not. Okay, so now for this, let us look at the photographs. So if you look at this photograph, so here in this photograph, basically we have Taj Mahal, photograph of the Taj Mahal. Okay, so you will at once say that they are the photographs of the same monument, that is Taj Mahal. Okay, but are in different sizes. They are in different sizes. Would you say that the three photographs are similar? Okay, so now question, would you say these three photos are similar or not? Okay, and our answer is yes. Yes, these figures are basically similar. So these figures are similar, but they are actually same. They are actually same photograph of they are actually photograph of the same monument Taj Mahal. Okay, and the shape of these three photographs are actually same. Okay, but the size of this size of the size of the photograph they are not same. Okay, but they are actually similar figures. Now, what can you say about the two photographs of the same size of the same person on at the age of 10 years and the other at the age of 40 years? And are these photographs similar? So now person is same, but age are different. Okay, ages are different. So what can you say about the two photographs of the same size of the same person? One at the age of 10 years and the other at the age of 40 years. Okay, and now question, are these photographs similar? So our answer, these photographs are of the same size, but certainly they are not of the same shape. Okay, so they are same size, but they are not of the same shape. Therefore, they are not similar. That means the two photographs of the same size of the same person, one at the age of 10 years and the other of the age of 40 years, these two photographs are not similar. Okay, now two polygons of the same number of sides are similar. So two polygons of the same number of sides are similar if number one, their corresponding angles are equal. Okay, so number one, their corresponding angles should be equal, and in number two, their corresponding sides are in the same ratio or proportion. Okay, so now this define when two figures are similar. That means two polygons of the same number of sides are similar if these two conditions hold. Okay, so number one condition, their corresponding angles are equal, and then number two, their corresponding sides are in the same ratio. Okay, so this is the definition of similar figures, and based on this definition, now we can see about two figures, they are similar or not. Okay, so for showing two figures are similar or not, basically we have to check first their corresponding angles if they are equal. Okay, and then we have to check their corresponding sides are in the same ratio or not. Okay, if their angle are equal, all angles are equal, and their corresponding sides are in the same ratio, then that two figures are said to be similar figures. Okay, now from the above you can easily say that quadrilaterals ABCD and PQRS from PQRS of figure 6.5. Okay, they are actually similar. Why they are similar? Because if we find the angle of this quadrilaterals ABCD, then you will get the angle A, this is 105, angle B, this is 100 100 degree. Okay, and angle C is 70 degree, and angle D is 85 degree. Okay, and here the length of this side AB is 1.5 centimeter, and the length of the side BC is 2.5 centimeter, and the length of DC is 2.4 centimeter, and the length of ED is 2.1 centimeter. Okay, and for this quadrilaterals PQRS, here the angle AC is 85 degree, angle P is 105 degree, and angle Q is 100 degree, and angle R is 70 degree. Okay, and the length of this side is 3.0 centimeter, length of this side is 5.0 centimeter, and the length of this side is 4.8 centimeter, and the length of this side SP is 4.2 centimeter. Okay, so here easily you can see the angle, all angle of this quadrilaterals and all angles of this quadrilaterals are basically equal. Okay, so all angles of these two quadrilaterals are equal. Now we have to check the the ratio of the sides. Okay, so here if we find the ratio of these sides, they are also equal. Okay, so from the above you can easily say that quadrilaterals ABCD and PQRS of the figure 6.5 are similar. Okay, and now remember, you can verify that if one polygon is similar to another polygon and second polygon is similar to the third polygon, then the first polygon is similar to the third polygon. Okay, so this is basically also called transitive property. Okay, you have studied about transitive property. In transitive property, basically, if one element is related to other element and other element is related to any other element, okay, then the one element is related to any other element. Okay, so you can verify that one polygon is similar to another polygon. Okay, and this second polygon, this is also similar to a third polygon. Okay, then the first polygon is similar to the third polygon. Okay, so you may note that in the two quadrilaterals, a square and a rectangle of the figure this, okay, figure 6.6, corresponding angles are equal, but their corresponding sides are not in the same ratio. Okay, so here, so the two quadrilaterals, this one is a square and another is a rectangle. Okay, so a square and a rectangle, they are not similar. So here you can see the figure. So this is the figure of a square. Okay, so for this figure, your angle all are 90 degree, but sides are 3 centimeter. And here, if you find the ratios, then you get basically 1. And here you can see angles all are 90 degree, but here this side is length 3.5 centimeter, this is 3 centimeter length, and this is 5 centimeter length, and this is 3 centimeter length. So for these two figures, their corresponding sides are not in the same ratio. Okay, but their corresponding angles are basically equal. Okay, So therefore, the two quadrilaterals, that is a square and a rectangle, are not similar. Okay. Now, similarly, you may note that in the two quadrilaterals, a square and a rhombus of figure 6.7. So if you see figure 6.7, here this is our square and this is our rhombus. So here you can observe that corresponding sides are the same ratio. So here the corresponding sides are 2.1 centimeter and here the corresponding sides are 4.2 centimeter. Okay, so ratio of this side, the corresponding sides are 1:1. Okay, for this the ratios of corresponding side is also 1:1. Okay, so corresponding sides are the same ratio, but their corresponding angles are not equal. Okay, again the two polygons coordinates are not similar. Okay, so these two quadrilaterals are not basically similar. Why they are not similar? Because because corresponding sides are the same, but their corresponding angles are not equal. So for being two figures are equal, their angles are corresponding angles would be equal, and also their corresponding sides are in the same ratio. Okay, then that two figures are said to be similar figures. Okay, otherwise they are not similar. Thus, either of the above two conditions, on and two, of similarity of two polygons is not sufficient for them to be similar. Okay, so they are necessary condition. So for condition 1 and 2, they are actually necessary conditions. They are not sufficient condition. Okay, now let us start exercise 6.1. Okay, so in first number question, here we have to fill in the blanks using the correct odd given in brackets. Okay, so we have given our some odds in bracket, and among these odds we have to find correct odd and fill in the blanks. Okay, so in first one we have all circles are actually similar, since the shape of all circles are same, but the size of all circles are not same. Okay, so all circles are not congruent. All circles are basically similar. Okay, and number two, all squares are similar also. So the reason is similar. All squares having same shape but do not have same size. That is why all squares are not congruent. All squares are similar. Okay, and number three, all dash triangles are similar. So here all equilateral triangle are similar, because for equilateral triangle all angles of the equilateral triangles are same, and their corresponding sides are of the same in ratio. Okay, so all equilateral triangles are similar. And in fourth, two polygons of the same number of sides are similar. Okay, and if their corresponding angle are two polygons of the same number of sides are similar if number A, their corresponding angles are same, and number B, their corresponding side are proportional, not equal, proportional. Okay, so their corresponding angles are equal and their corresponding sides are proportional. So for first one, the answer is similar. For second one, the answer is similar also. And for third one, the answer is equilateral. And fourth one, the answer is for A equal and for B is proportional. Okay. And question number 2, here in this question, it's said to us, give two different examples of pair of similar figures and non-similar figures. Okay. So we have to give different examples. So let us see examples. So two equilateral triangles with sides 1 centimeter and 2 centimeter. They are similar. Why they are similar? Because all corresponding angles are equal and their corresponding sides are proportional. Okay, that is why two equilateral triangles with sides on centimeter and 2 centimeter are equal, similar. Okay, and two square with sides 1 centimeter and 2 centimeter. So here, if we take two square with side 1 centimeter and 2 centimeter, then for these two figures, the corresponding angles are same. The corresponding angles are equal, and their corresponding sides are in the same ratio. Okay, so these two figures are similar figure. And now we take not similar figure. Okay, pair of two pair of not similar figures. So if we take trapezium and square, so this is our trapezium and this is our square. So here for trapezium, the corresponding angles for these two figures, the corresponding angles are not equal. Okay, so this is not a similar figures. Okay, and you can take triangle and parallelogram. So this is our triangle and this is our parallelogram. So their corresponding angles are not same, and also their corresponding sides are not in the same ratio. So they are not similar. Okay. Now let us move to question number 3. So in question number 3, here we have to state whether the following quadrilaterals are similar or not. Okay. So for this, here their corresponding sides are in the same ratio. Okay. So you can easily find their corresponding sides. They are actually in same ratio. Okay. But their corresponding angle are not equal. Okay, so these two figures are not similar. Okay, so quadrilateral PQRS and ABCD are not similar as their corresponding sides are proportional, that is 1:2, but their corresponding angles are not equal. Okay, so they are not similar. So I stop here this lecture. Thank you very much to all of you.